The diagram shows the curve with this equation. At the point P on the curve, the gradient is 4, and it is given that P is close to the point with coordinates here. Find dx dy in terms of y. Show that the y coordinate of P satisfies the equation here. By first using an iterative process based on the equation in part 2, find the coordinates of P, giving each coordinate correct to 3 decimal places. Okay, let's have a look at this then. So part 1, find dx dy, and we're told that x is equal to this. So x is equal to log n of y cubed plus 2y. So here, dx dy then, differentiate with respect to y. Dx dy on the left is equal to log of something goes to 1 over something, multiplied by the something differentiated, which is 3y squared, plus 2. Because we're simply differentiating with respect to the symbol y, so it's identical as if we were differentiating with respect to x, isn't it, if it were a function with the x symbols in. So that's what we get then. And that's what we needed to show, hopefully. Find the x dy. Okay, we've done that. Show that at P. So at P, we're told the gradient of P is 4. So here, for part 2, dx dy is 1 over dy dx, which is 1 over 4, is equal to this 3y squared plus 2 over y cubed plus 2y. More than one term, put brackets. So that tells us then that y cubed plus 2y is equal to 4 lots of this. 3y squared plus 2. And that tells us that 2y is equal to 12y squared plus 8. And then minus the y cubed. So what have we got here then? Well, let's hang on a minute. We've got the 12y squared plus 8 here, haven't we? So let's move that over. So we've got y cubed plus 2y. I see. So we don't want that line, do we? If we look at what we want to take a y out as common here on this line. And we're left with y squared plus 2 here is equal to the 3y squared plus 2. And that tells us then the y will equal 12y squared plus 8 over, and then this times can move from times to divide, y squared plus 2, which is what we wanted to show here. So use iteration to find the coordinates of P to 3D P. So the first value of y we can try as 12 and get the next value along. So let's put 12 in. So part 3 subs y equals 12 in right hand side repeatedly gives, so let's see what we get then. Y is equal to, so we'll do it repeatedly. Here's our calculator. We're going to sub in 12, so it's 12. Let's do equals, and that's the answer, right? So let's cancel that. So it's 12 times answer squared plus 8 divided by, now we need a bracket on the previous stuff, don't we, because it's on the top. So let's put a bracket around it. So that's the top, divided by the y squared plus 2, more than one term. Put a bracket, so it's ants squared plus 2, close bracket. And all we need to do is do equals. So we get 868 over 73. 868 over 73. The next one now. So equals again. 11.8884. 11.8884. And so on. So that tells us what y is equal to 3dp. So if we just keep pressing equals, eventually we can see that it's just going to be 888 to 3dp. 11.888 to 3 decimal places. Now we've got this very accurate number here, so I just press equals a few more times, and now we can use that as our value for x. So x is equal to, then here's the equation, log n of y cubed plus 2y is equal to, so this is now the answer, so it's natural logarithm, bracket of y cubed, so it's answer power 3 plus 2 times the answer, close bracket, equals 7.441, isn't it, to 3dp. That's to 3 decimal places. And there's our output values from the iteration process.